Okay, I have these three equations and I want to find the area, which we know from calculus, we find the area with integration between all of these. So what I have to do is figure out my A, the lower limit, and my B, the upper limit. Well, the only way to do that with this information is to just flat out graph it. So if I graph, and certainly y equals x is pretty easy to graph, right? Because that's that line, y equals x. If I want to graph 1 over the square root of x, well, think if x equals 1, and I plug in a 1 here, 1 over square root of 1 would be 1 over 1, which would be 1. So I know it's going through here, and this, instead of being a square root only going up, this is actually 1 over, so it's coming down. And you could plug in other points if you wanted to be able to see that. And then finally at x equals 2, just simply means when I'm out here at 2, I'm going up like that. So it should be pretty clear now. This is the in-between area, right? And that might be hard to certainly just be able to figure that out by looking at the equations. So I can see I'm finding the area between my lower limit of 1 and my upper limit of 2. All right, well, what are we finding the area of? Well, this is cutting it off, this piece. So I'm looking at the function above and the function below and subtracting those. Well, the function above is my y equals x, and my function below, this was 1 over square roots of x. And so I simply subtract those and find this, to be able to find this area. All right, well, from here we're pretty much home free. We find the antiderivative of x. Remember, antiderivative, you take whatever exponent there is. There's a loud motorcycle outside. And you add 1 to it, so it'll be 1 plus 1. And that becomes the bottom as well. This piece right here, what I like to do is remember 1 over the square root of x is the same as 1 over x to the 1/2. And then I bring the 1/2 to the top, and then I do my whole plus 1 business. So I have negative 1/2 plus 1, or 2 over 2 minus 1/2, which would be 1/2. So the top becomes x to the 1/2, which is the square root of x, right? So let me write that out here, x to the 1/2. And of course the bottom's the 1/2. Well, I'm going to bring that 2 up there, and it just makes it easier to be able to plug these values in. Okay, so antiderivatives, should be good at those by now, right? And now I plug in 2. So I have 2 squared over 2 minus 2 times the square root of 2. And then I plug in 1 squared over 2 minus 2 square root of 1. And however you do it, if you get an exact answer, or you want to actually, oops, I dropped something. You want to actually get the fractional value. My fractional value, I got 7 minus 4 square roots of 2, which ends up being approximately 0.67, which most of you'll just plug that in your calculator and get that for your final answer. And that's it. That's the area between this line and that curve.